I'm making this video to help you understand chemical equations. So when we have a chemical reaction, we can write a chemical equation to show what is going on in that reaction. So I have an example equation written down on the board. You'll notice some things right away. We have, on the left side, we have our reactants. Or starting substances. And then we have an arrow, yields or makes. And then on the right hand side, this is what is actually made, and these are called products. So we start with reactants. They react together and they form or yield these products. To balance an equation, and I'll address that in a future video, you change the numbers in front. So the blue numbers, the 3, the 2, there's nothing here, so it's assumed to be a 1, and the 3. These big blue numbers in the front are called coefficients. And we put those in when we're balancing. And it tells us how many of each thing we have. So for example, we have 3 atoms of copper here as a product. So coefficients are used in balancing. And when you're balancing, coefficients are the only thing that you get to change. The red numbers, 4, 2, 4, 3, those are called subscripts. And that's part of the formula for that particular substance. So we don't want to change those when balancing, because that would change it into something different. For example, if we had H2O, that's water. If we have H2O2, that's hydrogen peroxide, which is that stuff you put on cuts that foams and bubbles. Let's look at our equation here. And just a little more depth. So first of all, what type of equation is it? Well, we have a compound here. My abbreviation for compound is CPD. We have an element here. We have a compound here. So how do I know that? Well, when I look at this, I see aluminum, sulfur, and oxygen. If it contains different elements, then it's a compound. And this one's just copper. It's an element by itself. When we have a reaction that has an element on the left side and an element on the right side of the arrow, that is called a single replacement reaction. Sometimes it's called single displacement. Means the same thing. Let's look a little bit more in depth at our aluminum sulfate here, because that's our most complicated one. It's got parentheses in it. It's got 3 little subscripts in there. So let's look at that one in a little bit more depth. I do have a video on classifying reactions that you may want to watch if you didn't understand the single replacement part. So let's look at our aluminum sulfate. So Al2, SO4, 3. If we want to figure out how many atoms of each element are in this compound, and we need to do that in order to get it balanced correctly, aluminum, that little 2 goes with the aluminum. So the element that it's hanging off of, that's what it's indicating. So the bottom, there's like basically 4 quadrants around an element reserved for different things. And in a formula, you're using that bottom right-hand corner to indicate how many aluminums you have. If it's an ion, that's its charge, and we use these left-hand ones for mass and protons when we're doing nuclear reactions. So that little 2 goes just with the aluminum. So we have 2 aluminum atoms. Now if we look at our sulfate, we have 3 whole sulfates. So this 3 distributes into both the sulfur and the oxygen. You can think of it this way. If we wrote it out, we'd have aluminum, sulfate, 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 3 sulfates. So we have 1, 2, 3 sulfur atoms. For the oxygen, each sulfate has 4. This 4 goes just with the oxygen. So each sulfate, SO4, has 4 oxygens, but we have 3 sulfates. So we have to multiply these two together, 3 times 4. And again, you can think of it this way. We've got 4 oxygens here, plus another 4 here, plus another 4 here, to get 12 oxygen atoms. And this is important when you're balancing to know how many you have on each side, and also when you're figuring out the mass of this compound. You would have to add 2 aluminums, 3 sulfurs, and 12 oxygen masses to get the mass of the entire compound. The last thing I want to talk about is the arrow. So the arrow can look different. Usually when you're first starting out basic biology, you're going to see an arrow pointing to the right. That means that these reactants are reacting and forming these products. But sometimes you'll see an arrow that points both ways, and that means it's a reversible reaction. So not only will the reactants react to form products, the products can react and work backwards and reform the reactants. So it can go in both directions. Another thing you may see, for example, in biology, you saw this over the photosynthesis reaction. Sometimes over the arrow, you'll have something written. Like for photosynthesis, you need light or energy in order to make that reaction go. And so we'd have our reactants on the left. It requires light, but it's not actually a reactant. but it needs that to form the products. Sometimes you use a catalyst to speed up a reaction, and that catalyst would be written up here. Whatever its formula is, will be written above the arrow, because a catalyst is something that you add to the reaction to speed it up, but it's not used up by the reaction. So you don't want to put it as a reactant or a product, because you're not making it and you're not using it up. You are just sort of borrowing it to speed up the reaction, but you get it back at the end. That's pretty much it for chemical reactions, some of the basics of those. I hope this has helped. Please like and subscribe and tune in for the next chemistry video.